You know, inside pretty much every piece of electronics you own, your phone, your car, you name it, there are these little unsung heroes. They're tiny components doing some of the most important jobs imaginable. We see them all over circuit boards, but what are they actually doing?
Well, think about a camera flash for a second. That sudden, brilliant burst of light, that's a massive amount of energy getting released in a split second. Where in the world does that kind of power come from?
See, a regular battery, it's kind of like a marathon runner. It's built for slow and steady power delivery. But a camera flash, that thing needs a sprinter. So the battery has to pass the baton to a partner that's built for an explosive burst of speed.
And that partner is the capacitor. It's one of the most fundamental passive components in all of electronics. Now, passive just means it doesn't create energy on its own, but it is an absolute master at storing it up and then letting it go in a hurry.
And if you're not convinced of how important these things are, just look at the money. The global market for capacitors is on track to hit almost $32 billion by 2028. We're not talking about some niche part here. This is a cornerstone of the entire tech industry.
All right, so what's the big deal? What makes them so special? The absolute easiest way to wrap your head around a capacitor is to just think of it as a tiny, incredibly fast battery. Let's dig into how that works. At its core, a capacitor is all about storing electrical energy. But here's the key difference. A battery stores energy using a chemical reaction. A capacitor, it stores that energy in an electric field. And that one little difference is what allows it to charge up and, more importantly, discharge almost instantly.
And what's so cool about a capacitor is just how simple it is. I mean, every single one, no matter how big or small, comes down to this basic setup. You've got two conductive plates called electrodes, and they're separated by an insulator, which has a fancy name, a dielectric. Slap on some metal wires to connect it to a circuit, and that's the whole thing. The magic is all about how these simple parts play together.
So how does it charge up?
Well, you hook it up to a power source, and right away, electrons start flooding onto one of the plates, making it negatively charged. This pushes away the electrons on the plate across from it, leaving that one with a positive charge. And that imbalance creates this powerful electric field in the insulator between them. Just like that, energy is stored right there in that field, ready to be unleashed.
You know, this charging process, it isn't just a straight line. And there's this fantastic analogy for it. It's like building a brick wall. When you start, you can lay down bricks really fast. But as the wall gets higher, it gets tougher, and you start to slow down. A capacitor is exactly the same. It gobbles up charge really fast at first, but as the voltage builds up, the flow of electrons slows down to a trickle, right until it's full. But of course, it's not a one-size-fits-all situation. Not all capacitors are created equal. Just like you'd use a different hammer for a different kind of nail, engineers pick and choose different capacitors for very specific jobs. Let's meet a few members of the family. The type of insulator, that dielectric material we talked about, is usually what defines what a capacitor is good at. Ceramic capacitors, awesome for filtering out high-frequency noise. Electrolytic ones can store a huge amount of charge, so you see them in power supplies all the time. Film capacitors are super stable, which makes them perfect for high-end audio gear. And then you have trimmers, which are adjustable, so you can use them to fine-tune a circuit, like on a radio.
Okay, now this is where things get really interesting, and a little weird. It's not just the type of capacitor that matters, it's how you wire them up. And here's the thing that trips up everybody when they're starting out. They behave the exact opposite of resistors. If you put capacitors in parallel, like side by side, their storage capacity, their capacitance, actually adds up. But if you line them up in series, their total capacity goes down. It's a critical, totally counterintuitive rule every circuit designer has to know.
All right, so we've got the what and the how. Now let's get to the fun part. What do these things actually do out in the wild? They have an amazing range of jobs. Job number one, the most obvious one, is energy storage. In this really simple circuit, when we flip that switch, the capacitor just dumps its stored energy to light up the LED for a quick flash. This is the exact same idea that lets laptops and phones stay on for a split second while you swap out the battery so you don't lose all your data.
But here's where they show their real genius. They do so much more. Take a look at this volume control circuit. Here, the capacitors are acting like bouncers at a club. They block the steady, boring DC voltage, but they let the fluctuating AC audio signal pass right through. This is what keeps you from hearing that awful scratchy noise when you turn the volume knob on an old stereo.
And that really shows you how incredibly versatile they are. I mean, a capacitor's resume is just packed. They provide temporary power, they link different parts of a circuit together, they block noise, they control timing and signals, and they even give motors that initial kick they need to get started. They are the ultimate electronic multitaskers.
And that really brings us back to where we started, you know? In the super complex world of modern electronics, it's so often the simplest little components that are doing all the heavy lifting.
So next time you pick up your phone, or listen to music, or see a camera flash go off, just take a second to remember the tiny, powerful capacitors working away inside. They're the silent partners, the essential invisible building blocks that make our whole digital world possible.
And this story is far from over. The next evolution is already here. Supercapacitors. These things can store absolutely enormous amounts of energy. They're already being used in electric cars to capture braking energy and to help start massive engines. So the real question isn't just what they do now, but what incredible things will these unsung heroes make possible next?